All right, here we go. So now we're going to construct dilations, okay? So here's our notation for the dilation that they want us to do, okay? And remember, your compass copies measurements and moves them elsewhere on the page, wherever you need them, right? Yeah, that's right. What? Okay. So in this particular case, we have a point here. What our center of dilation is right here, point O. And we're going to dilate segment AB how many times? 3 times, right? So what I want you to do is read this over. It's pretty simple, actually, okay? And see if you can replicate it. So you measure the original distance, just like we're doing in the coordinate plane, right? The original distance, and we need 3 of them, don't we? Now listen carefully, because what I'm about to tell you is going to help you when we get to one with a negative scale factor, okay? We need 3 of these distances to triple it, don't we? Now, when we're going in this direction, we already have one of them. And I hinted towards this the other day, right? We already have one of these distances. So we only have to add how many more? For a total of, right, 3 times original distance. Okay? But since one of the distances was already here, we only need 2 more to triple it. You got that? So now thinking ahead, right? If we're going to do a scale factor of -3, right? It'd go out this side, wouldn't it? It would go out this way. And you'd need not to add 2 more, but how many? All 3 of them, because the first one is not on this side like it is here. Right? So there's a common mistake kids make, is you get so used to, oh, I'm just going to add 2 more. Oh, if it's -3, just add 2 more. That first distance, the first of the 3 is already there. That's why. It's not already here on this side. Okay? So then they finish it up there and then label it A prime, B prime. That's not hard, is it? No. So,
Is that all this is?
given that, go to this next page here and do this dilation.
It's like 5 steps ahead of that already.
Quietly. Quietly. And I will, skinny. But we won't. That's right. I mean, you guys did enough
We're taking in so much information.
partying and assemblies in middle school to last a lifetime. We don't need to do any more.
We had like 1 a year. Yeah, that's true.
Okay. Every time announcements came on.
Bottom of 7th and 8th grade, please report to this.
Now they're winning $10 gift card.
Yeah.
Yeah.
All right, come on, White Dallas, get this done.
No, you could buy that kind of toilet paper. We got food that's gonna move. There's some cards.
So let's measure the original distance for this guy. There. I think that's about, yes, right there. Now, carry that distance up here. Mark. Tack on the 3rd of the 3, because the first one's already there for the tripling, right? And now measure this distance here. Slightly different. Yep. Always do that.
Yeah, I lost.
Because that's like, on the Regents exam, you have some real complex problem, and you forget to label it, and you get, if it's 4 pointer, -1, right? Which by a couple of you did that on the test there, and I had to crush your soul.
Never that. You gotta make sure you get exactly on the point, or you're already on mine.
There's some reasonable degrees of error, right, that are allowable, but then sometimes it's just, God, no. Can't have a gap like that. All right. So this is A prime and B prime. Anybody have a problem with that? No. Okay. Now how about this next one down? Well, okay, hold on now.
You have to find the angle segment bisector, perpendicular bisector.
So you're gonna need to draw your rays in here, right? So now it's a dilation of 1.5. The first one distance is here. So what do we have to tack on after that? The 0.5. How do we get half of the original distance? Which construction? Perpendicular bisector. And then you measure out to that mark that you made with the perpendicular bisector. Okay? Let's put our rays in there. I might even make this smaller. So let's get our rays in here. Like that.
That makes perfect.
All right, so for 1.5, our distance of 1 is already included because the figure is right there. So we need that half. So we're going to just do a little perpendicular bisector.
Wait, do we gotta find the perpendicular bisector of AB too?
No. Just all we're doing is dilating the distances from the center. That'll take care of it. Once we dilate these two distances, AB will be dilated to the correct size. Right? So over halfway, right? Mark there. We'll mark down here. Flip around, right? You know how to do this. Please tell me how to do this. That one. Bring it around. Cross that guy.
Wait, why?
Why what?
Why can't
I'm trying to find the midpoint.
I know, but why can't I just go a little bit over the half and then go up and then?
That's perpendicular bisector. Yeah.
What are you doing?
I'm just not drawing the full arcs. All right? I just want to keep it clean. Remember I told you at some point you want to kind of start doing that. Because now, look, you're going to have to do the other segment now, and it's going to start to get a little messy because you got all that in there. You might get confused about, oh, wait, which one was I this, right? So it's best to try and neaten it up a bit. So I get my straight edge. Like that. I gotta do like a shortening. I don't
That
know.
does not look.
Huh?
That does not look like.
So I'm only to like right there. Mine's gonna be because this stupid thing is so stupid. I can't just do it. So there's what I'm gonna measure here, right? That's for my half. Turn. Yeah. What? I heard Mr. Hefner, and
Really did it.
okay. Now I'm gonna take that distance a half and just tack. There you go. Now you just got to do the other one, right? Perpendicular bisector, but I'm not going to draw it in because it'll get messy. So here, make a little mark. There. Flip it. Come over. Just get them to cross. I did hit it. Good. Almost missed it. Oh! I'm going to hit that one. I got it. Now, of course, mine's going to be off. I can't off that. And all I need is this little mark here. So you guys are seeing what I'm doing, right?
Yeah.
I need that 1/2 to tack on at the end, so I gotta find that, measure it, tack it on at the end. Got my straight edge gun. From here to here. And here is my A prime, B prime. We all good with the, like, you got 2.5 or 1.5 now, right? If it was 2.5, what would we do first? We have to take this distance, put it out here, then go back and get the half and tack it on. Yeah. So
Take common sense.
What part are you missing here? Were you able to draw the rays?
Yeah.
Okay. Were you able to get this midpoint?
Yep.
Really? You answer me, I could walk it. You know how to do the perpendicular bisector?
Yeah,
Well, that's how we're finding the midpoint.
yeah, I know that.
Well, what is it you're missing?
I want it to look like that.
Oh, perhaps you just measured wrong. What do you guys, look at hers and see if you
How do you get the second thing?
figure out what you
How do you
did.
get the second point?
This?
Yeah.
Perpendicular bisector again.
That's the second.
I had to find the midpoint of this segment and that segment.
Oh, I did that segment first.
Right. I did this, measured it, and put it on. Then I did this one, measured it, and put it on. Okay? Okay. So we all got this one. There is a Regents question. We're now going to dilate, not a segment, but a triangle. Okay? So take a moment. Scale factor is 2. I see so many times a kid will just say, oh, I'm going to dilate this triangle and not read where the center and just pick the wrong point to be the center for some reason. Because they hadn't read. Okay? So again, draw your rays in there, right?
What do I draw?
Well, that's a good question. What's the center of dilation?
See.
It is? Did you read it?
B.
You must read. Must read.
But
Yes.
still, I B through N.
Well, yeah, just like on the other one we just did, you had it from the center, you drew your ray through the points you wanted to dilate.
Yeah, but it's already blind to, so I just draw them longer.
Yeah, you need them, because they're going to get bigger, right? You need more, right.
And they are parallel. The dialect.
And that's true, and there's more than that. All right, quietly get your lunch. Don't turn it into recess, okay? Get it? Sit down, be quiet, keep doing this.
4 pizzas?
Oops, no, that one.
Yeah.
So let me extend this one out, about like that, maybe. Extend that guy out. And our scale factor, I believe, is 2.
One more pizza.
Well, Carter, did you get pizza?
Oh. Carrots?
I didn't get anything. No, I didn't. No, 100%.
Yeah, you did. I really thought you did.
I remember that too.
Oh, yeah, you did because.
Yeah, so you want
Yeah, you said that, yeah.
No, but I unselected it because I have
No, no, you didn't.
I swear to God I did.
You still need
Get
to
your
get
pizza.
I go to the bathroom.
I want to put my.
After you finish this.
Oh, I'm like first.
Hey, Carter. Carter. I said after you finish. Oh, you're just getting your lunch. Okay.
I'm so no, but I'm just confused.
Guys, can we quiet down? Is anybody wondering where point B goes? What do we do with point B? What about that? It's one of those invariant points, right? It is the center. Oh, this. Guys, I want you.
Oh, I want the Travis guy.
This is pepperoni right here. This is a pepperoni thing.
Yeah.
Little thing.
Now, somebody tell me if I done this. Quiet down. Look up here. Have I done this completely correctly? Am I missing anything?
Yes.
What am I missing?
Your P equals B1.
Thank you. There we go. Got some learning going on out there.
See, you know what to do.
Okay.
Yeah, these ones.
Everybody okay with that?
Yes.
Lily? Good?
I'm not.
Lily's good.
Equals B5. Oh, yeah.
Yeah, it's an invariant point, right? Now let's answer this question down here. We need to think about what happens with dilations.
They're parallel.
What's parallel to what?
AC,
Paragraph. The
is parallel to A.
So AC is parallel to A segment A prime, C prime. Well, and what else? That are congruent. We doubled the size. I doubt they're congruent. Unless we're in McCarty land. Huh? Well, the question's not about, that's true. The questions are not about the angles. Look at the questions, about the two segments, right? So we didn't even talk about angles here. What else do we know about how the two segments relate?
DCA for
Look at the, do you see any question about angles here?
DC is double. Congruent to C.
no.
AC is
Not right.
Similar.
AC and A prime C prime segments. They're congruent? Well, let's look at them.
Oh,
My hands
What are they? How do they relate? What was the scale factor?
2.
So,
Double.
okay, so what do we say?
That AC is double. AC double. I don't know how to say it.
So the new segment AC prime is equal to twice AB, isn't it?
That's what I do.
That's,
No,
I got
it's
that.
twice AC, not 2.
Oh, I'm sorry, I wrote AB.
I
Thank you.
didn't do that. I didn't do that.
I got that.
AC.
Never makes mistakes.
Not that.
The image is twice the size of the pre-image. By the way, what else, this is important, what else did we study that would deal with this? What else could you think of this as? Not too long ago.
I would say we're playing soccer.
Triangle mid-segment. Remember? Wouldn't this, since we doubled it, wouldn't A and C now be the midpoints of these two sides of the triangle?
Oh, yeah.
Making AC the mid-segment of the triangle?
Yep.
What two things do we know about triangle mid-segments compared to the third side?
Parallel.
Parallel and
Double.
twice away. So isn't this really a triangle mid-segment?
Yes.
I mean, you wouldn't need to put this here in the regions, right? But I want you guys to make these connections. So I'll just put it parenthetically. You know what parenthetically means? Sorry. Inside parentheses. Okay? That's only one, right?
Wait a second.
Okay. All right.
Knock them in the